presentation for the big solution of the energy storage. Now we're coming down to, let's say, the small commercial part, which is, from my opinion, also very interesting, because this is at the moment one market which is really moving forward. Beside the big energy storage market, yeah, the residential market now is more or less a bit weak. Yeah? So I will give you a short presentation. Let me see. So when you go to small commercial systems, you will face some different kind of problems. But first of all, I will do a short presentation what we are doing. So I'm now more than 40 years in the PV industry. Did installation, did solar cells, did inverters, and so on. So now we are focusing on energy storage system and EMS systems. So what is also one key, what you need to supply is you need to help your customers for planning. You need to have the right products. Naturally, delivery and distribution, let's say that's not that difficult. But then comes the more difficult part, the training of the installers and the after-sales service. And the after-sales service is one point which is for most suppliers a weak point, I have to say. Yeah. And naturally, at the end, if you get end of lifetime, you also need to think about what you are doing with your products. So we're doing, let's say, different sizes. We have different experience in these different sizes of battery storage systems. We also do have our own 10 kilowatt inverters hybrid and the battery and BMS technology for that. So when we are talking about EMS, so energy management system, this is it's difficult to find what is the definition of energy management, because when you look at those people, they're thinking, okay, you just need to know, you need to follow the paperwork. That's one point. Yeah? Then it's also, let's say, any energy management. But on the other hand, you also need to have a look what is the real energy flow in a system. So about the paperwork, this is what I'm talking about. Energy management is known as ISO 5001. But this is, from my opinion, it's mainly paperwork. Yeah, you need to have a structure that you can follow and show, okay, I'm increasing my, let's say, energy savings. But it's not helping really to save energy. It's just to show how I could do, but we need to come to the point we need to do. Yeah? And the next point naturally is also, and that's also one point about the security and safety. Yeah. So with all of this decentralization and the flexibility, there is a risk for the cybersecurity. So for ISO 5001, in principle, those are the tasks you need to fulfill. But at the end, you still need to face the problem, okay, I'm producing energy, I have an energy storage, so what I need to do. Yeah? And this is what we see and what we are helping. Yeah? So you have existing power plants, you want to extend your system with battery, So how you integrate all those things in one system, that it's working. So therefore you need to have an energy management hardware and software that you can manage all, let's say, all the needs for you as a customer. Yeah? There is you need to cap the peak. You need to control multi-battery connections. Naturally, you want to have optimization of your self-consumption. You need to have you need to control the feeding and all those points. So it's getting more and more complex. And this is how we help for the customer. So for a single house, that's not really complex. So that's more or less easy. Naturally, it also there are coming more and more wishes. Yeah. So I want to have a wall box. I want to have to charge my heat pump. I want to do other switchings and so on. Yeah. So and then you come to the level. Okay. Is this working fully automatically, or what I need to do? Yeah. So, but this is for us still a simple task. Yeah. So, what is, let's say, the most points in those systems? Yeah. So, you need really to measure the relevant inputs and outputs. Yeah. So you need to have a smart meter. You have PV inverters or battery storage systems. Yeah. You need to have an algorithm which follows in a short time the energy flows, because energy flows can change very fast. And it's also a need to have access to energy generators and to the storage systems. And you also need to have a response of your system. So you send a command, so what happens? Yeah? So, and all those things, you also need to, let's say, record that you can, for example, find out what was the problem when I was in holiday and suddenly the system was crashing. This can happen. Yeah? So, therefore, I want to show an example of one system. So the now I need to check what we can do here. Yeah. So the customer had an old PV system, and still the modules are working. Also the inverters. Yeah. So, and he wanted to add for peak shaving additional system with 250 kilowatt hybrid inverter and 250 kilowatt PV inverter, but he got a limitation from the utility. You only can feed in 200 kilowatt. Yeah. So we need to fulfill the limitation to the grid, and we need to do and organize the peak shaving for him that he comes down with the cost. That was the other point, because it was a production company. So at the end, this was the real situation. So here, this one is the old system, and those are the new ones. So here you see the hybrid inverters. These are the batteries, and these are the PV inverters. And with this device, we control all. Because each of them, let's say one inverter, they cannot control everything. So you need to have a system above that you can control all those devices. So this is what the customers see at the end. Yeah? You see what he's producing, what he's consuming, what he feeds into the grid, what is the battery status. You see all the production. We are managing 2 battery storage systems. So we can add even more, yeah, to work in parallel with those systems. And naturally, you need to give him, let's say, the rules, what we need to do with the PJ. So, and this is at the end what was, let's say, how you can see what is the help with the battery. Yeah, this was because battery at that time was important for the system. Yeah, because in February was not that sunny. Yeah, so and to cover the peaks, you need to have enough in the battery that you really can cover the peaks. And from that time, so you charge during nighttime, and you use the energy for cutting the peaks. Yeah? And this is, let's say, how we do the limits. Yeah? And there you see, so here we operate with the battery to cover the peaks. So, this is another system. This is also very interesting, because this customer wanted to have to charge his battery during winter time. So he installed a 200 kilowatt PV and 3 10 kilowatt hybrid inverters with each 40 kilowatt battery. And we also operate those batteries completely parallel. So it's operated by the EMS, not by the inverters. Inverters cannot do. And there's also a next, let's say, application, that's multi-family houses. Yeah? So you need to control what is the consumption of each flat. Yeah? And here you can add the systems. Yeah? You can add, let's say it's like a puzzle. Yeah? You're doing, okay, this customer needs to have this one, this one, this one, yeah, and you just add it. And we all control with the energy manager. So this is one example what we did here. Yeah. So it's also one battery system, and no, he has no battery, but he wants to control all his meters. Yeah. You cannot believe how many different wishes customers can have. Yeah. So the other topic for energy management systems is naturally it's always increasing, let's say, the requirements, what you need to fulfill. Yeah. So also the variable electricity tariff, so that you need to know, okay, when the grid is cheap, when it's more expensive. Yeah. This you also need to implement so that you really can work with all those system suppliers who will offer, okay, at that time you get this price or this price, yeah, so that you can have a win out of the system. But those systems, I have to say, only make sense if you really have possibility to have a big storage like an electric car. Yeah? Because for a normal household it's too less. Because when you have let's say a low price, yeah, you also produce a lot of energy. So where you put it, yeah, you need to have a big consumer for that. Then it's really valuable to add those variable electricity. So, and naturally, this is the biggest rule at the moment, which is, let's say, very difficult. Yeah, because there's a lot of misunderstandings, still there is, let's say, a lot of points to discuss, yeah. That's the paragraph 14a, so that the utility is allowed to reduce your draw from the grid of 4.2 kilowatt for 2 hours a day. And you can get some additional benefits when you're using an EMS, because then you can use your own production, your own battery, to cover more loads, not only the 4.2 kilowatt. If you do not have an EMS, you are limited to 4.2 kilowatt. So those are all functions you need to implement into an EMS system. And there's another point. So when you are more than 130 kilowatt, you also need to do a direct marketing of your production. So this you also need to implement in an EMS. Yeah. So there are, so the complexity is getting more and more, and you need to be able to fulfill all those, let's say, needs to come at the end, and this is the topic out of that, to come at the end to a stable energy grid. Yeah, because this is all, it's all related to, let's say, that the utility is able to control the grid. So, then there are some other points. Sorry for some German, but at the moment this is, I only get it as a picture. I do not. So the big discussion also also related to the EMS is how you charge your battery. Yeah. So the standard systems, they charge the battery when the sun is shining and you have excess power, and the excess power goes to the battery. But this is not, let's say, when you have lots of PV installed, it's not what the grid really needs. So you need to have, in principle, you need to fill your battery during the peak time. Yeah, this is more grid services, what you can offer. Yeah. And there are, let's say, some expertise about that, about the battery lifetime. But there we need to have a look at it. Yeah, they say, okay, when you charge the battery at the end of the day, the lifetime of your battery is increasing. I will catch up for that. Yeah, because they say when you charge the battery late at the day, you save 8 hours of fully charging the battery. So, but this is only important to when you, let's say, when your battery is full and you still keep charging. Yeah, then I agree for that. But if you have, let's say, a more intelligent battery management system, there's no need for that. I will show you. Yeah? Because here they say, okay, you can increase the lifetime of your battery for 2 years when you charge the battery at the end of the day. Yeah? Only the point is when you still keep charging the battery if it's full. Most batteries on the market are doing like that. Nobody knows, but they are doing. We measured that. So, I will show you. I showed you one system with this 200 kilowatt, and this is exactly the data out of this system. Yeah. So this guy, because he has a big PV, really could get within 3 years 850 cycles on the battery. That's really impressive. Yeah. Because normally in a standard household you have about 200, 220 cycles per year. Yeah. But because he can charge the battery nearly through the whole year, yeah, he gets also a lot of cycles on the battery. Yeah? So what we can see, normally, this is what they say here, yeah, normally they say, okay, you get a decrease of 2% of the capacity of your battery. And so in this case, we should come to a capacity, when I calculate 2%, at 4,700 watt hours. Yeah? We still have more, so we have less decrease of the capacity. Yeah? This has one reason. Our BMS is doing, at the moment, still one of the onlyest one on the market who's doing top balancing. So we do all battery cells keep on the same level when they are fully charged. So each battery cell really has the same energy content. And if we achieve that, then we shut down the charging. So we do not keep on charging. Most systems on the market, they keep on charging each second, a short peak. And this increases the lifetime, this decreases the lifetime of the battery. Therefore, they say when you charge the battery later on the day, yeah, you can save hours, and during the lifetime you can gain about 2 years. Yeah? But it's only related how you do the BMS of the battery. So we have same systems with the same inverter running, but with other battery. Yeah? And there we really see, these are real measurements. Yeah? There we really can see, okay, this supplier keeps this 2% decrease per year, exactly. Yeah? After 527 cycles, this customer does not have such a big PV system. Yeah? But in principle, you can see, so this is the standard. Yeah? But still, there can be some improvements also for the battery lifetime. So this is also one thing about, let's say, how you're charging the battery. Yeah? It's always related to how you control the battery with your EMS. Because normally the systems in a hybrid inverters or in a battery inverters, they do not have this function integrated. Yeah? And therefore you also see here again, so this is the peak, the price of the electricity. Yeah? When you're not following the charging during noontime, yeah, you feed in when the price is very low. So at the end you have less earnings. Yeah? So when you can follow here, charging the battery during noontime, yeah, it will at the end lead to one point. Yeah? In principle, when you're doing like that, you can earn about 28% more, because you feed into the grid when the grid price is more high, and you do not consume from the grid, or you do not feed into the grid when the price is low. Yeah? So this was my presentation for the EMS. So hopefully you got some interesting points out of it.
Okay, thank you so much.